In acute triangle ABC, L is the bisector of BAC. M is the midpoint of BC. A line through M parallel to L meets AC, AB at EF, respectively. Given AE equals 1, EF equals root 3, and AB equals 21, the sum of all possible values of BC can be expressed as root A plus root B, where A, B are positive integers. What is A plus B? This is triangle ABC, where L is the bisector of angle BAC. The point D, where it intersects BC, can be either to the left or right of M, depending on AB and AC. If AB is less than AC, as in this triangle, then AB over AC is less than 1. And AB over AC by angle bisector theorem is equal to BD over DC. So we know that BD over DC is less than 1, so BD is less than DC, and M will be to the right of D. We are given that there's a line through M parallel to L that meets AC and AB at E and F, respectively. And we're also given that AE equals 1, EF equals root 3, and AB equals 21. So let's zoom in on triangle AEF to see if we can get any more info about the triangle and triangle ABC. Well, first, note that this angle here, DAE, is equal to angle AEF by alternate interior angles because those two lines are parallel. So this angle is equal to this one over here. But also, angle AFE is equal to this angle here. I'll do that in a different color. This one here is equal to this one here because also the lines are parallel. And since those two angles are equal, it's an angle bisector. We have that triangle AEF is isosceles, so AF is also equal to 1. And 1 root 3 means that this is a 120-degree angle triangle, so that basically means that angle A is equal to 60. Now we can use Menelaus's theorem on triangle ABC with transversal MEF. Using Menelaus's theorem, we get BM over MC times CE over EA times AF over FB is equal to 1. But BM over MC is by definition equal to 1, since M is the midpoint of BC. So we don't need to write that. We have CE over EA times AF. AF is 1. And FB is 1 plus 21, which is 22, equals 1. CE over EA is 1 equals 22. So we have CE equals 22. And CA equals 22 plus 1, which is 23. Now using law of cosines on triangle ABC with sides AB and AC and angle A equals 60 degrees, we can find the value of BC. We have BC squared equals 21 squared plus 23 squared minus 2 times 21 times 23 times cosine 60. But cosine 60 is just 1/2, and 2 times 1/2 is 1. So BC squared is just 21 squared plus 23 squared minus 21 times 23. That's 441 plus 529 minus 483. That's 970 minus 483, which is just 487. So in this case, BC equals the square root of 487. This is not the only possible value of BC. We also have another case where AB is greater than AC. Then by the angle bisector theorem, we have BD over DC is equal to AB over AC, which is greater than 1. We assumed AB is greater than AC, so AB over AC is greater than 1. And since BD over DC is greater than 1, we have BD is greater than DC. So D appears to the right of M, since M is the midpoint of BC. The line through M that's parallel to L, let's do some angle chasing again. We have that these two angles are equal on the angle bisector, AD. We have the same alternate interior angles. This angle here is equal to this one because of the parallel lines. And this one here, the blue one, is equal to this one by alternate interior angles. So triangle AEF is still isosceles with AE equals AF equals 1 and EF equals root 3. And AB equals 21. So we have BF equals 20. And using Menelaus's theorem, again, we get BM over MC times CE over EA times AF over FB equals 1. But once again, BM over MC is equal to 1. CE over EA is just CE, because EA is 1, times AF over FB. AF is 1 and FB is 20, equals 1. So we know that CE is equal to 20. And therefore CA is equal to 20 minus EA, which is 20 minus 1, or 19. So we have CA is 19 and AB is 21. Applying the law of cosines once again, we have BC squared equals 19 squared plus 21 squared minus 2 times 19 times 21 times cosine A. And cosine A is just 1/2 because A is 60. We know that angle EAF is 120 because 1, 1, and root 3. Therefore, A must be 180 minus 120, which is 60. And then cosine A is just 1/2. 2 times 1/2 is 1. We just want 19 squared plus 21 squared minus 19 times 21. That's 361 plus 441 minus 399. And that's 802 minus 399, which is 403. So in this case, we have BC equals the square root of 403. These are the only two possible values of BC. Their sum can be expressed as root A plus root B, where A and B are positive integers. A is 487 and B is 403. A plus B is 890. Thank you for watching, and please follow my channel if you would like to see more videos.